So we said that ionic bonds were kind of like magnets. So I've got some magnets here that I want to look at. So we're going to pretend that this is hydrochloric acid and this is sodium hydroxide, and we're mushing the two together and creating that neutralization reaction. And we're going to have water molecules, but then we're also going to have some positive sodium ions and some negative chlorine ions that get separated and are floating around in the water. And so I want you to pretend that the space in between each of these magnets is water molecules. So any place that you see black table, it's actually supposed to be a water molecule that's there. All right, so these are sodium, positive sodium, and negative chlorine ions that we created. We separated out because we mixed together hydrochloric acid and sodium hydroxide, and they neutralized each other, and they made water, and then they made all these ions. We've got all these positive sodium and negative chlorine ions floating around in the water. Now, obviously, that's where I need to stop. So as the water starts to evaporate, that means that the space between these positive hydrogens and negative chlorines is becoming smaller. And so as that space goes away, eventually, because one's positively charged and one's negatively charged, they snap together. And so now we have salt water. That wasn't supposed to happen just yet. That is technically what happens, but I don't want it to happen just yet. Okay, seriously, this is getting silly. So now we have our salt molecules. Our positive sodium and our negative chlorine have snapped together because the water between them has evaporated away, and we've ended up with all of these salt molecules floating in the water. But the water continues to evaporate away. And as it does, because the positive side of the sodium is still attractive and the negative side of the chlorine is still attractive, we now get these lines of salt molecules that have all stuck together. And then the water continues to evaporate and they continue to be brought closer together. And we end up with it connecting into longer strands. And then it's also attractive on all four sides. So now we start to get sheets of salt crystals being formed. And then eventually, because it's still attractive on all four sides, it's also attractive on the top and bottom, they end up sticking together like that. And of course, we would get a much prettier crystal from actual ions, but we then get a salt crystal that's left down in the bottom of our glass of water. So all the water has evaporated away and all the salt has clicked together into a nice little salt crystal.